Hello all, today we are going to be learning about 8.1 geometric mean. The geometric mean of two positive numbers a and b is the number x such that you can set up this proportion, and basically it solves so that you just end up multiplying two numbers and then taking the square root of them. So normally you would, in a normal mean, you would add the numbers and then you would divide by how many numbers there are. A geometric mean, you multiply numbers and then you take the square root. So for example, like you have here, if 9 and 4 are your a and b, you just go ahead and multiply those and then you take the square root of that. And in this case, it's a really nice number. It is just the number 6. Okay? So we have another example here. Say we have the numbers 2 and 5. What is the geometric mean of these? So we go ahead and multiply them. We take the square root of that, and we get that our answer is 10. That's the geometric mean. Okay? If we try another example, find the geometric mean of these. We're just going to go ahead and take 3 times 12. That's 36. Take the square root of that, and that gives us 6. Now, not always is every problem going to be a perfect square. For example, if we try something different, let's do, say, 4 and 12. If we're trying to find the geometric mean of these, you go ahead and you multiply them. You get 48. And then you have to take the square root of this. Now, it's not a perfect square. We also want to just reduce radicals and not get decimal answers for now. So we have to go ahead and do our factor tree here. Oops. And then figure out what the reduced form of this. So it would be, in the end, after we group these, 4 root 3. Okay? So this would be the geometric mean after reducing of this problem. Some of them will be nice. Perfect squares, though. All right? Now, we have geometric mean. We're going to move into using shapes, triangles specifically, to come up with a problem to solve for the geometric mean. So if we have an altitude, that's this line CD, it's drawn from a vertex straight down at 90 degrees, to the hypotenuse of a right triangle, then the two triangles formed are similar to the original big triangle. So you can write similarity statements between the small triangle, the medium triangle, and the gigantic triangle. So we're going to do that in this example. You can come up with just arbitrary angle measures to help you out. So if I say, okay, E is 70 degrees, this angle here has to be 20, just because triangles have 180 degrees. And then keep going, that has to be 70, and then angle G has to be 20. So if I'm writing my similarity statement, I'll go ahead and say triangle. If I go E, F, H for my small left side triangle, and then since I did 70, 20, 90 on my right side triangle, I'm going to have to do 70, 20, and 90 as well. So this will be triangle FGH. And then for my gigantic triangle, I'm going to have to do 70, 20, 90 again. So E, oops, don't forget the triangle. E, G, F. Okay, so just make sure you put them in order of congruent angles so that you make sure the triangles are actually marked congruent. All right. All right, so moving on. Similar thing down here, you can give yourself different arbitrary angles if you want to. And then just figure out which of these four is the actual similarity statement. You can pause me here, just look through them. Okay, so your actual answer is C. If you checked your triangles for their similarity, C is the correct one. All right, now here's the real meat of the lesson, our right triangle geometric mean theorems. So we've previously talked about how you can just set up proportions when you have similar triangles. So you could still do that here. We have 3 similar triangles. You can just find corresponding sides and set up your proportions. There's also kind of a shorter way you can think about these things. Then this is when you have specifically an altitude or a leg of your gigantic triangle given to you. So first thing, if you are given the altitude or you're trying to find the altitude, that is going to be a repeated part in your proportion. So we're still going to set up a proportion and cross multiply to solve, like we would if we were doing similar triangle stuff, but this is kind of our shortcut. So this will guarantee our proportion is set up correctly. Altitude is repeated. One's on the bottom, one's on the top. Your other 2 pieces, if given an altitude, will be the 2 parts formed by the hypotenuse, so x and y in this case. And then you'll just cross multiply to solve. On the geometric mean leg theorem, say you're given the leg B, that leg will be your repeated part, and then you have the whole hypotenuse over the little piece of that triangle. So same thing every time if you're given a leg, because if we look over at this A side, we're going to have A repeated since it's the leg. C is the hypotenuse, and then the little piece Y is the other missing information. So if you can set up with this information and solve a proportion, you should be good to go. Okay, so we're going to do these examples. We're going to find C, D, and E. I'm going to start by solving for E. It's the altitude. It's the one that's slightly different. We do know the altitude, though, is our repeated piece. Sometimes it's a variable, like it is in this case. Sometimes it's a number and you're trying to solve for something different. That is fine. So E is repeated, the altitude, and then when we're given our altitude, we use the 2 smaller pieces formed by the hypotenuse, okay? So we have 6 and 24. You go ahead and cross multiply, you get E squared equals 144. And hey, that's pretty nice because the square root of 144 is a perfect square, and our answer for E is 12. Now, in some cases, like in this case, you could actually now transition over and use the Pythagorean theorem to find C. Most times that would be okay. I want to go ahead and use our new information, though, and do the geometric mean leg theorem to find C and D on this problem. So I'm going to do D first. I have D. It is a leg. That means it is the repeated part of this problem. And then my other 2 parts, 6 corresponds with that. And then I need the whole hypotenuse here. So I'll go ahead and cross multiply. I get D squared is equal to 180. And I will have to take the square root. Now, I know this isn't a perfect square, and I don't want to get a decimal answer, so I need to go ahead and factor tree to simplify. So I have 2 and 2 and 5 and 3 and 3. I got down to just primes. So I'm going to write those out. And then I'm going to circle groups of 2 numbers and pull 1 out from each of those groups. So now I have 2 times 3, root 5, which is just 6 root 5 as my answer for D. Okay, make sure. We want reduced radicals right now. The instructions will usually say how they want the answer. So make sure to read those. And then C, we can solve very similar to D. Its numbers are just going to be bigger. We have our leg C, so that's going to be the repeated piece. And then the corresponding side here is 24. And then we need the whole hypotenuse, once again, 30. Notice, when you're solving for a leg, you don't use the altitude information. So we don't use that 12. Okay? So we'll go ahead and cross multiply. We get C squared. I don't know what this is. 24 times 30 is 720. Once again, not a perfect square, so we can go ahead and factor tree it. These should get pretty fast. I kind of find factor trees pretty fun because they're just the same process every time. So you end up getting the square root of 2 times 2 times 2. 4 of them. I don't remember how many I said. Times 3 times 3 times 5. Group them up. We end up having 2 times 2 times 3, which is 12 with a root 5 left over for C. And that is your solution. Okay? So you can go from not knowing much about a triangle to knowing a lot about it if it's a right triangle with an altitude. This next one, you'll notice they don't actually ask us to do a reduced radical. We can see by the answer choices that it's either going to be just a decimal or a whole number. So we can go ahead and set that up. And we only have to solve for E. So even though F is in the picture, we don't have to do that. So E is a leg of the gigantic triangle, so it will be our repeated piece. And then we are going to do the corresponding piece, 16, over the whole thing, 20. So we have E squared equals, let's see, what's 16 times 20? 320, and then you just take the square root of that, and we get 17.9. So that's C. So E is equal to 17.9. Answer choice C. We could have had to have done a reduced radical once again, but since our answer choices were not that way, we can write a decimal. All right, we're actually going to skip this problem. And then this next part is not the same homework as you have. All right, so this is your worksheet. You'll notice that you're asked to just find the geometric mean here. So you're just going to multiply the two numbers and then write in simplified radical form. So say for number 2, you're going to do 18 times 10. That's just 180, and then you take the square root of that. And then you go ahead and you just simplify it down. We've seen square root of 180 a lot recently. We have 2 times 2 times 3 times 3 times 5, which reduces to 6 root 5. Because these two come to the front. 2 times 3 is 6. Okay? So you'll do a similar thing here. I will say 5 is a little different because of this decimal. You could technically do a lot of simplifying for this, but just go ahead and write root of whatever that decimal is, and that will call simplified enough. Okay? Otherwise, the rest should be pretty simple. 7 and 8, you'll go ahead and do triangle something is similar to triangle something is similar to triangle something for both of those. 9 through 14, you're going to do factor trees. So say we tried 10, you'll go ahead and factor tree this. I don't know what 98 divided by 2 is. 49. And then you'll have 6 root 2 times 7 times 7, but 7 can come to the front. So 6 times 7 root 2 is just 42 root 2. Okay? You can try 9 and 11. Pretty simple. 12, you have 3 root 3 and 3 root 3. Now, these numbers in front are what you can multiply. So we end up getting 36 root 3 on the top. This is called rationalizing if you don't remember. Once again, the numbers in front can multiply, so you have 3 times 3 is 9. And the numbers inside can also multiply, so root 9. The thing is, root 9 is actually the same as just 3. So this is equal to 9 times 3, which is 27. And then we want to check if these diagonals reduce. And they do. So we actually end up getting 4 root 3 divided by 3 because you can divide 36 and 27 both by 9. And one thing on 14, 13 is easy. 14, 12 is actually reducible. So make sure, or simplifiable, make sure to simplify this. I don't care if you do it before or after you rationalize, just 12 you can simplify. Now 15 and 16, these are like what we did on the notes. You've got a leg here. You can solve for x, that'll be your repeated piece. You've got the altitude here. You can solve for x, that'll be your repeated piece. Now notice you're going to have to find this to finish your problem. And then make sure also to write your answer in simplified radical. Once again, 17, you've got your altitude. You'll just have to find this guy. 18 again is an altitude. You'll have to find that piece. 19 through 22 are a little different. We haven't seen any problems like this yet. Notice you are given the altitude, but you're not finding it. You're finding another portion. That's fine. The altitude is still the repeated piece. And then you'll just fill in the other information and cross multiply to solve. You're not going to get a squared. You're not going to get a square root answer. The answer on these type are actually kind of easier. You'll just repeat something other than your variable. And if we look at 22 as well, the leg here you are given, that will be your repeated piece. And then you once again, you'll have to use the 3 as one of it and the whole hypotenuse as the other, x there. And you'll just cross multiply to solve. I will say real quick here, when you're doing 2 root 3 times 2 root 3, we just saw this above. You'll want to multiply these two numbers and multiply these two numbers. So you end up getting 4 root 9. But the square root of 9 is actually 3. So this will just be 12 equals 3x. And 20 will actually look very similar to that. Make sure to finish solving for x on both 19 and 22. And then 23 and 24, they're a little different as well. I would suggest on all of these start solving for x first and then go from there. That'll be helpful information, okay? So solve for x, y, and z. Make sure to simplify your radicals. Otherwise, that's all I've got for you. Have a great evening.